Today I'm going to look at a JVC R76 that was sent in by a viewer that has no sound and just some distortion on the radio. And he has a complete set of instructions as to what he wants done on this thing. So this one's going to take me a while because I'm going to have to take this whole thing all apart to meet the customer's expectations to get this one serviced and sent back to the client. Let's take a look at this one. Today I have a JVC R76. This is a receiver. I know it looks like separate components, but it actually isn't. It's just a receiver with what it's made to look like a separate tuner, but it's not. They're all in one box. No sound is the complaint on this. We're going to check all the inputs out and check out the outputs and see where the problem is. So right now I'm trying to tune in my test transmitter. Oh, might help if I actually put some music on it. So here's the AM band. I'm not hearing anything, or very little. And the FM band is nothing. I've got my test transmitter tuned in, but I don't hear any sound. What we're going to do is we're going to check the record outputs and see whether there's any signal coming out of the actual tuner itself. Connecting the record outputs to my test amp, I can hear that there's nothing on the record outputs for tape 1. Tape 2, distortion. Go to AM, same thing, distortion.
Before, especially since his family weren't talking.
And that's essentially the same thing I get, but even worse going through the output. So let's take the top off this thing and start tracing electrons. So here's a look in the top of this unit. From the symptom that I'm getting, the severe distortion, I'm thinking maybe we're missing one of the supply voltages. So I guess the first thing to check is to see whether I've got my, I think it's a plus 15 and a minus 15 volts going over to the tuner. So let's just turn the unit on. We'll ground one side of the meter here. Let me grab a jumper for that. Get our ground reference. And we'll check our voltages here. Plus 15. That's about 13 volts. That should be okay. And our minus 15. We got no negative voltage. There's probably our problem. Our negative 15 volts is missing. That's going to the tuner. And of course, it will be going to other circuits as well. So now we have to determine why we've lost the negative 15 volts. I'm just going to pull the bottom off of this unit to access the bottom of the board so we can get a better look at what's in the bottom of this unit. Now I should warn you guys right now, this is going to be a relatively long video as I was working on this unit all day. Okay, the minus 15 supply comes in from here, the top terminal up here. I'm just going to lower the camera down a bit so you guys can see it a little easier. Now the camera might be in my way though, but we'll try. This is the minus 15 supply. If I turn this on, this is where we're looking at right here. I have nothing. And if I follow that back, back to this pin here, which I've still got 0.5 volts. Nothing here. We're following the source back to here, 0.5. I wonder if we've got any negative supply voltage at all. So there's our positive 60. There's our negative 60, so we know our supplies are working. They will be available on the output transistors. But our voltage divider here is where we're losing it. 36 volts here on this Zener. 36 volts. 0. 0. 0. 0. 0. And 0. Interesting. There's a resistor here, 36 volts. 36 volts, that's okay. And negative supply is fed from here, negative 61. I know, if I dug out the schematic it would be easier. And I do have the schematic for this thing. But quite often this is not necessary. I can just trace by eye to see where things go. This is a supply here, 60 volts. And my negative supply comes down from here, 1.5. That's fed off of this transistor here, 0.5, 0.0. Okay. So Q803 emitter is the input for the regulator, and that is not getting any voltage. The collector is the output, and that should be fed from the emitter. Did I say emitter? Collector, sorry. The collector is fed from R804. That's a fusible resistor, so we're going to find R804. R804 should be down here somewhere. R804 is right here. We have nothing on one side. We have minus 60 volts on the other. So this resistor is going to be open. That one right there. R804. If we look at the meter here, I got the partial schematic here. R804, if we look down at the meter, this side's got 0, this side's got negative 60 volts. So we'll start out by replacing that fusible resistor and see if there's any other damage besides that. So first I'll wait for the voltage to dissipate. Take a few minutes here, and then we'll change that resistor out. If we look down the board here, R804 is toasty. Also deal with these Zener diodes here that are obviously, the connections are bad. Watch what happens if I just touch the diodes on the other side here. These here, these are cracked. You can see them moving, see? So they got to be resoldered. Oh, that's one that's been removed. Just going to remove R804 here. We'll replace this. So I have a 68 ohm quarter watt resistor to replace that one with. I just noticed that one of my lights is out in here. No wonder it appears dark. Like I can't see what I'm doing. One of the lights in the ceiling has burned out. It didn't last very long. CFL bulbs, right? Joke. But I got this great flashlight, so fantastic flashlight. I was using a little BLF special edition in the shop here. It's great. Okay, we'll solder down that resistor. There's two more parts across here, D811 and C14. What is it here? What did I say? C814. I've got, across this, I've got 1.9 ohms. And D814 is a Zener diode. And that might be shorted. Maybe not. Maybe this capacitor is bad. There's a regulator across here. And it's, D810. What did I check there? D810. D810, here it is. D810 is measuring 2 ohms. And C14. I'm just going to remove one side of either one of those and see whether there's where the short is. Something shorted and took out this resistor. I haven't powered it up. I just disconnected one leg of it here before I power it up. Just want to make sure there's no other shorts. And it looks like there is. Either this capacitor is shorted or this diode. So I'm just going to lift one leg of it and see whether it's the diode or whether it's the capacitor that is shorted. We'll measure both the capacitor and the diode. First the capacitor. No short there. And the diode. 2 ohms. Now I think that diode is shot. It's a D8. That's a D810. Let's see if I can find something that's comparable to that. So I need a total, I need a 16 volt Zener, and I don't have one. But what I do have is I have a couple that were included with this unit that were spares. I have a 5.1 and an 11. So I'm going to put the 5.1 and 11 in series, and that will give me my required 16 volts that we can replace on the board and get this thing working. So I've got my 2 Zener diodes put together right here, and I'm going to put them into the board to replace the one that's shorted. Okay, I think this thing is probably ready to put some power to it now and see whether we get anything. That's not good. So as I continue to look for the short, because I still have a short on this circuit, I had a short across the emitter collector that was of, or emitter base, sorry, collector base of Q803. And there's a capacitor C813, a 0.47 microfarad cap right across the base collector junction. So I've just disconnected that and now my short is gone. And if I measure it right to the cap itself, that capacitor looks like it's shorted. Yes, it is. Interesting. Let's remove that capacitor. I do believe this is it here, and it looks like it's burnt. Looks like it's burnt. That might be the culprit that caused the fusible resistor to burn up in the first place. We do not see any leakage across a ceramic capacitor, especially 64 ohms. No, that should not be. This little ceramic capacitor is shot. It's shorted. So I'm going to go and replace that fusible resistor again that popped when I powered it up, and we'll try and find one of these things. I'm sure I've got one around here somewhere that will work, and we'll give it another go. So I got another little ceramic cap here that's a little bit bigger. This one's the other one was a 47 picofarad. This is a 56, but it's just, these are just a bypassed capacitor, so the size of them really isn't all that important. These are just to take out noise and stuff, right? I'm working blind in the shop today because I say some of my lights aren't working in here. I'm going to power this unit up. I've got my variac turned down to lower voltage. So I want to see if anything happens when I hit the power button. Make sure nothing's going to go up in smoke. That might not be. Oh, voltage isn't quite high enough for it to come on. There we go.
Now, I don't know how we accepted that. And at one point, there was an SEC...
We got sound. Let's turn the power up to full power. So we're at 120 volts now. Radio's working.
A whole host of China companies listed in the U.S.
My test transmitter. And FM. Everything's working here. And CD input, tape. So switching's good. Gotta remove this little board here to change the light bulbs that apparently that are burned out on here. Fuse bulbs that apparently are burned out. They look like it, but they aren't lighting. Yeah, they're open. Okay, I got two new 12 volt lamps here. Okay, now the fuse bulbs are replaced. The display lights up. See if the power meters come back. And the power meters now work. Now, you'll notice that this one has, somebody has removed two of the Zener Diodes from the board. They were D815 and D812. And what they appear to be, I haven't looked at the full schematic, but they appear to be to provide voltage to the meter ICs in the event of how it's wired. Is it looks like, I should go to look at the full schematic here, but the actual lights are providing the power for the power meters, because if I take out the lights, you'll notice that the power meters won't work. I've seen this happen before on these units, and I'm trying to recall, but I think there was a bulletin issued, because I used to be a JVC warranty depot, work at a warranty depot that did JVC and Panasonic and Sony. And I recall reading somewhere that they had removed a couple of those Zener diodes. They were used to bias the panel meters on in the event that the light bulbs failed, so that the meters would continue to work. But there was a problem with them overheating and causing other problems, so they clipped them out, and the panel meters power is drawn through the light bulbs. So if the light bulbs go open, the power meters stop working. I do recall, this is going back so many years, because this thing's so old. This is from like the early 1990s, I think 1990, 91. So the last time I worked on one of these units would have been probably the mid 90s. I remember working on one of these units here and having to take out the Zener diodes, because when the light bulbs failed, they were there to provide power to continue the operation of the power meters, but they caused problems. They overheated. I'm going to go over what the fault with this unit was, which caused the distorted sound from the tuner and everything else to fall apart. What we had was we had a missing negative, they call it a negative 15 supply, but it's usually around 13 volts. But our negative supply was missing in action. And the negative regulator is right in this area here. Let's see if I can get a bit closer picture of it here. My print isn't very good. It's hard to read. It's really hard for me to see because it's so small. But this is the Q803. Q803 is the negative regulator. And what happened on this unit was the owner of the unit, this was actually a shipped in repair from one of my viewers, but and I'll tell you guys, if you want to ship me something to repair, if it's coming from the States, do not declare a value on the unit that's coming in for repair, because if you put a value on it, the customs will assign GST and PST. And this one here, the fellow that shipped it to me, he put a declared value of $600 on this thing, and it ended up costing him $103 just to bring it into Canada for it to be repaired, because the customs people, they see a value and they tax it. They convert the US funds to Canadian funds and they tax it. So anybody that's going to send anything into Canada, whether it's to me or to anybody else, you have to declare it with a value of less than $20 or you will be assessed tax. And if you ship it by means such as FedEx or UPS, they will add a brokering charge on top of that. Whereas the post office doesn't add a brokering charge, but you get nailed tax. I've had lots of things sent to me for repair over the years, and I've never ever had tax assessed on anything. I get lots of new products. I get amplifiers that are worth $100 sent in, and cameras that are worth $50 or $60 or $100. I've even had video projectors sent in, brand new products on for demo, like to do demo videos on, and I've never had to pay any tax on any of them because when they're shipped as a sample with no commercial value, or they're valued at $2 or $3. I think that amplifier that I just showed you guys, that little digital amp, the last video, those things sell for like $150 on Amazon. But I look at the weigh bill on it, and it was assessed at like $4.50. They do that just so that there's no tax. So if you ship anything to Canada, keep that in mind. If you declare a value of more than $20 on it, whoever's receiving it is going to get hit with a huge amount of tax. It's 12% based on whatever the declared value is. And something of this age has no value, especially when it doesn't work. Okay, so what happened on this one is I think water got into the unit. The fellow that owns it said he was cleaning it and he was using a cloth that was damp and maybe some water got into it. But whatever caused it, this little capacitor here soaked up some water and turned into a resistor. Basically caused a dead short, which in turn drew too much current, because you see normally your minus 36 volts comes in here from the power supply. Where are we here? I've got to look at it here. I'm looking at the monitor. Here's the negative supply here. This is the rail here. Right? I'm having to draw this looking at the monitor. But it comes up here and it goes through this fusible resistor, and then it goes into the collector of the regulator transistor. But it also goes down through this 10K resistor here to be referenced on this Zener diode. Now what happened when this capacitor shorted is, well, it became less than 10K, which provided full 36 volt down through this Zener diode here and shorted out the Zener diode, burnt up the resistor. Okay, I found the Zener diode, no problem. And I found the resistor, no problem. Okay, why didn't I find the capacitor? Well, I wasn't looking for it. You're not looking for a ceramic cap that shorts. The chances of a ceramic capacitor shorting are so remote. Electrolytics can fail, sure. The paper caps used in the old tube radios, yeah, absolutely. Ceramic caps themselves are generally pretty darn reliable. So I changed out the 68 ohm resistor, changed out the Zener diode that was shorted, put power to it, but the Zener I put in was a higher wattage Zener, otherwise it would have popped as well. It burned up the resistor, but did not short the new diode, which was good. So then we had to go back and look at it, and oh, this stupid capacitor has failed. So we changed the capacitor. That gets our voltage back, gets our negative supply back. Now the other thing that this problem that this thing has, it's not really a problem, but I talked about it before, and I'll explain what it is. A lot of these units have D812 and D815 removed. This one had them cut out. This was a very common repair, and it was actually a modification that came out on this unit by JVC when I was servicing these. I remember that they said cut those diodes out. For whenever you serviced one, cut those diodes out. What the diodes do is, if you notice here, you've got a supply voltage coming up, and it goes up here through the light bulb in the front display, through one bulb, and then back through the other, and down this way, and then into this 3 diode stack, which is 3 5.1 volt Zener diodes to ground. It's 37 volts that's coming off the emitter of this transistor. So you get 37 volts going in, to the two lights and coming back, and it's clamped at 15, which will give you about 11 volts per light. So normally, under normal circumstances, these Zener diodes are not conducting at all. But what they're there for is, they were there for when the lights burned out, so that the circuit would continue to draw power, because if you're not drawing any power through here, the meters themselves, or the power meters, are not going to work, because they're picking their power up through the circuit as well. Anyway, the Zeners were put in there so that if the bulbs failed, the panel lights would continue to operate. And if one bulb failed, the other one would continue to go. Right as it sits now, if one bulb fails, because they're in series, both the lights go out. So if one bulb failed, the Zener that was across the open pilot lamp would conduct and continue to operate the circuit, and your power meter lights would continue to flash to the music, your output power, and everything would be happy. If both bulbs failed, they would also continue to operate. The problem that happened with these units is, again, they would overheat. And generally they wouldn't overheat if the lights were still good, but if you had one or both bulbs fail and these diodes were put into operation, they would overheat and short. And then it would shut the whole thing down, because now you're into an overcurrent situation and the whole thing would go down on it. So the modification bulletin that was released back in the early 90s was to remove these Zener diodes, and this one's had them already clipped out of them because they were a problem area. So when you see that, if you see one of these things and D815 and D812 are missing, then that's generally the reason why. Now the fellow that sent me, he sent me a bunch of parts from this. He put them in little plastic bags and he marked which ones were which. And he gave me a D811, it gave me a D812 and D815. And lo and behold, when I tested them, they're both shot. Check this out. So he sent me two of them from another, he has another identical machine. So he saw that this one had missing Zeners in it. So he pulled some Zeners out of his identical parts machine and sent them to me. But here we go. Here's the two of them. He labeled them both where they came from, D812 and D815. So here's the meter on one. As you can see, this one here is open both ways. So there's one direction. And I'll switch the wires around. And there's the other one. It's open. And the other one, we test this one. 0.6 volt drop. That looks good. But when we turn it around, 0.4. This one's shorted. That is what happens to these Zener diodes when the lights fail. And that's why we get these out of this circuit on these units. If you see one of these units here, those Zener diodes need to go, because all they're there for is to keep the lights running and to keep the power meters going when the lights fail. So not necessary, causes lots of headaches down the road. Better get rid of them. Another big headache on these is these particular Zener diodes here. They get very hot because they're passing out a fair bit of current. They're handling all the current that's going through both of these lights, so they do tend to get hot, and the solder connections tend to crystallize and get dry on the bottom of the board, so they need to be resoldered on it. But anyway, that's a little look at this circuit on this thing and what was causing the problems on this unit. I've still got work to do on here because the guy that owns this wants me to do some other stuff to it as well. So we'll continue the video as I continue to go through what he wants to have checked out on here. Other things that need to be done when servicing these units is to check the ground screws to make sure that they are tight. The ground screws are these ones that have got metal brackets around them. So we'll check this one here. I'm looking at the monitor, I can't see what I'm doing. You can see that this one's not very tight. These need to be tightened down because they provide ground to the board for the main chassis. As you can see, here's the Zener diode that I've replaced. I went and put one in that I had. Just had to go find one. And this is the capacitor here that was causing the problem. That went Nova. Client also wants me to replace the thermal compound on the transistors, even though that's usually not necessary. But they want it done, so we'll take a look and see whether it needs to be done first. I got the power turned off here, so I'll just remove one of the transistors and we'll take a look behind it and see whether the thermal compound needs to be replaced. Alright, I shouldn't say I'll remove the transistor, I'll remove the screws, and we'll take a look behind here and just see what the compound looks like. A lot of these don't even use thermal compound, they just use these insulators, which have got, yeah, you see this one here doesn't even use thermal compound, it's part of this insulator, right? So I mean, I can put some thermal compound down here, it won't hurt it, but this insulator is part of it, so I can put some thermal compound on the insulator and put it back in there. But see, that's the original one, and they didn't even have anything on there at all. So we'll put some thermal compound in on these insulators and put them back in, and then we're going to check for conductive circuit glue that gives a lot of problems, and clean up the board and get this one ready to go back home. So that's one done. 3 more to go. That's 3 of them done. I have to pull these 2 capacitors out to get the screw out for the last one. But you can see I've got new heatsink compound on 3 of the 4 outputs. We're going to pull these caps out because the client wants the board cleaned up here anyway. So let's do that now. One. And there's the other. As you can see, these caps, there's nothing leaking out of this, it was just circuit glue, but the caps themselves look to be in excellent shape. So now we'll clean up some of this crud that's on the board here. It's old circuit glue, we're going to scrape this out of the way. Okay, now I can get at that last transistor. Take out the screw on it. First we'll check the capacitor's ESR, or equivalent series resistance, which is going to be very low because these are huge capacitors. So here goes. If I can get my probes to cooperate. 0.6. That's good. 0.7. My fluke won't go beyond about 5600 microfarads, so I'm going to pull out the other meter, which should be able to give me the reading of these caps, the capacity of them. Yep. 10,450 looks like. See, it's gone from microfarads to amp farads. So that means it's going into the megafarads range. So 10.49. These should be like 10. So that one's good. Do the same on this one. $10.54. They're both over spec because they're 10,000. So 10,500 on one and 10,490 on the other. So that's they're good. Both of those caps are fine. We'll put them back in the unit now. Okay, let's test the unit out again. I've got it on AM. AM's good AM quality sound, right? If it was an AM stereo receiver, it would sound really good, but it's AM mono, so we have to listen to it in mono quality. Switch to FM. I don't have an antenna on this thing, so as far as I've got a piece of wire on here, but that's all. Don't have much in the way of an antenna. Goes pretty bloody loud. 125 watts. Oh, it's 110 watts per channel. But meters will peak at 125. But I had it pretty close to maximum power there. It was pretty loud. Let's check some of the other inputs on this thing. Go check the CD input. Don't hear any leak through either. Oh yeah, on the tape monitor too you will. You might hear a little bit. That's pretty normal on these things. You try tape number 2 input. Pull volume control out here and see if we can get that crappy Sony Bond stuff that they put on. It's that circuit glue, that yellow glue. It's called Sony Bond. Yeah. It's funny because Sony never used it on their own stuff. They just sold it to everybody else. It should come out. This is the crap that I'm referring to. This yellow glue down here, the circuit glue, this stuff is murder. What happens is it goes corrosive, and then it becomes conductive as well after a while. So if you got this stuff on your board, it's probably not a bad idea just to try and pick it off as best you can. This stuff hasn't gone bad yet, but when it goes bad, it turns like it. Right now, it's still pretty pliable, but when it does go bad, it turns like a brown, crusty, hard, flaky type glue. Right now, it feels still pretty pliable. When it gets to that brown state, it starts to get quite resistive, and then you get signals leaking across where they shouldn't be, and causing problems. Of course, this stuff was on here to keep the wires from being pulled away from the board. That's why it was put there. So we're just going to remove what we can of this stuff. The only way to get all of this crappy circuit glue out of here is I actually have to take the front panel off, and I have to remove the board because there's more of it on the front side of this board where wires are connected down. So unfortunately, I got to take this whole thing apart to get rid of this crappy conductive going glue that was put on at the factory to keep wires from getting dislocated during the assembly process and during transportation and stuff. But it's all got to come out for reliability. So I need to remove all the arrow mark screws on the board here in order to remove the board to get access to the top side so that I can scrape that crap off. Already got the crap taken off of the volume connector here, but I got to take this board out as well. And I probably just opened a whole can of worms here. I think all these stupid buttons are going to fall out now. Why did I do this? Okay, now the board can lift relatively free. So we can see this crap that's got to come out of here, right? All this crud down here and up here, this circuit glue. It's got to go. I can clean the balance control while I'm in here because I now have accessibility to the balance control itself. So here's the crap I'm talking about here. This stuff here has got to go. Right, there's the circuit glue. There's some more of it down here. And there's some more of it over here by the volume control. So we're going to just pick this off, and then I'll actually clean these controls. I'll put some deoxit onto these controls while I've got it apart. Give them a shot of cleaner. And then I can start reassembling this thing. As you can see, this is starting to go right here. It's starting to turn the color. It's starting to go brown. So this one here is not far off. We just pick it off with some pliers here and just peel the stuff off, basically. Oops. Now I gotta fix a broken wire. Because the wire pulled through the board here when I was working on this. Damn. So while I was picking off this glue, one of the wires here pulled free from the board. So that's why they put the glue on in the first place, was to keep the wires intact while they were putting the unit together. But it's gone now, so I've got most of it off. It's off of anything that's going to cause a problem at this point. So let's clean the controls and start putting this thing back together. Okay, I cleaned all the controls with deoxit. It's gonna be fun. It's gonna be a lot of fun putting this thing back together. Wow. It's maybe I've turned it up on the side, it might make it a little bit easier. Try and hold everything in place while the board goes back in place. Okay, here's one screw in place. Gotta get the screws here for it. So I just had to get this to snap in, I just had to adjust the headphone jack position. Got the base held in place. A couple more screws to hold the side brackets in. Okay, now it all nicely lights up. Controls are nice and quiet. So the client gives me a checklist of everything he wants done. He wants the analog switch IC302 swapped, so I'm going to swap it off. He sent me a donor board. This one, there seems to be a bit of leakage. If I crank it up, there seems to be a bit of sound leakage. So client thinks maybe the IC, there might be some internal leakage. I think it's highly unlikely, but it's at their request. They're paying for it, so I'm changing the IC. So let's pull the back board out and we'll swap that IC over. First I'll remove the old, or the donor IC from the donor board. The new IC from the donor board, I should say. The old IC from the donor board. Hope it works. With the old IC lifted off the board. So to remove the back board, I have to remove the screws that hold the board to the back. And then we can pop out that IC, pop in the replacement one, and see whether it makes any difference to the crosstalk from one channel to another. Could be a bad IC that's causing it, but usually it's not. Usually those ICs themselves just don't have very good isolation, because it's quite a common thing. I can say that with confidence because I have an amp that uses electronic switching, and mine does it too, and it's done it since day one. So I don't think it's going to make any difference at all, but I've been asked to change it, so I will. And there's the prize that we're changing right there. Okay, same procedure. We'll use the solder wick to remove the solder from the IC and just pop out the old one and pop the other old one back in. Easy peasy. When I used to work in the business, I used to watch my assistant. He'd waste this stuff. Even the shop owner would waste the stuff, and then they'd complain about how much it was costing for solder wick. And none of them knew how to use it right. This is the right way to do it. You know, I mean, I take out an IC, I'm only using like an inch of the stuff, because you can actually get a lot of solder into here. But I've seen the way some people do it, and you know, they'll have one little spot of solder on there, and then they'll move up an inch of wick. And that's not necessary, because the stuff will draw a lot of solder into it, just like that. It does a really good job if you do it right. Unfortunately, a lot of people don't do it right. Looking good. I'll bag the old chip back into a anti-static bag. So that's how much solder wick I used to change 2 ICs. About 2 inches. Length of a finger. That's pretty good utilization of this stuff. As I say though, I've seen so many people, including all the guys I used to work with, including the shop owner, that they would use about a foot of it to change one little IC like that. It was just ridiculous. And then they would complain and say, we're not ordering any more of that stuff because it's too expensive. Use your solder pump. I had a mechanical solder pump. I actually had an electric one as well. The problem with the electric one was that the tips would get clogged up, and the tips were really expensive. And the tips would get clogged up, and it was like, you know, I think at the time they were probably $10 or $15 for a tip, and it would last about a week or two at the most, and then it would get clogged up. We had these, like a piece of stainless steel wire that you jam through the end of the tip to try and clean it, but it would disintegrate from the inside out. And so the boss would get mad at that, and he'd want us to use these ones with the spring load. Well, the problem with those things is, well, half the time they end up splashing more solder on the board than you're taking off. So I used to use a wick and never ever had any issues with it myself. Okay, let's see how this thing performs now. Okay, it's working. Let's see if this one has bleed through like the other one did. Yes, it does. I called it before I changed it, but the checklist that I got here of things that he wanted done, he says, do everything that's highlighted. And the analog switching IC was highlighted, so it got changed, but I kind of knew what the outcome was going to be. Just because all those analog switches are slightly leaky, there's not 100% isolation on any of them. So that's taking care of that. There's a few other things he wants me to check on this. I've done the corrosive glue. Check the DC offset. There won't be any DC offset anyway, because if there were, the protection circuit would cut the protection relay out, but we'll check it. Okay, we have 0.009 volts. Go to the other channel and check it. Same thing, 0.006. We have no DC leaking through to the speakers, or such a low level that it's negligible. You can barely measure it. So I think that solves that, or answers that question. A few other things he's got on there is to check the idling current. Well, the idling current should not need to be ever adjusted on a receiver or an amplifier unless you've changed components in the output. That's the bias, and the only time you really would ever need to do that is if you change the outputs or change any of the driver components. These use precision resistors. The resistors themselves aren't likely to start changing value, so that's really kind of a moot point to check the idle current. Can be done, but it's not going to show anything because there's no fault. That's something that you have to do if you change parts. If you change output transistors or change the driver transistors or replace any of the components in the amplifier, then you got to set up the idle current, because every transistor is going to be slightly different, right? And that's what the idle current is to compensate for, slight variations in components. But once it's set at the factory, providing that no parts have failed and no parts have been changed, it's not something that you normally have to do during part of normal maintenance. It was also requested that I resolder the speaker terminals, so let's do that now. Now comes the time where we do preventative maintenance. So I'm looking at connections like here, which I guess it's hard to see with the flashlight on camera, but I'm looking at these ones here with my magnifiers, and these ones here I can see are starting to crack. This connector here, So I'm going to resolder those and everything else. It looks, that one connector up top here between the tuner and the main board here. This connector doesn't look great. I'm also going to do the headphone jack down here in the bottom. Okay, the unit's ready to go back together. Now, one last thing we have to test, and that's the phono input. So I'm going to grab a turntable, plug it in, and we'll check that out. Okay, got the turntable hooked up. Let's see if we can play a little Monty.
Sit on my face and tell me that you love me. I'll sit on your face and tell you I love you too. No fun at a nigger.
And now for something completely different.
The world today seems absolutely crackers. I like Chinese. I like Chinese.
Okay, it's working. You can put the top back on it now and complete the job. Oh, got it back together. Just take off the cabinet protecting tape that I always put on the side that I'm going to have on the bench when I'm working on the unit. That way we prevent any scratches. Little tip from the pros. I didn't tape the whole front because I didn't have it upside down. I only had it on one side. So I taped the side that's going to be on the ground or against the bench to prevent any scratches. There you go. All done. Thanks for watching. We'll catch you guys in the next one. Bye for now.